Hello, everybody. Thank you for joining our Gen Chem session number 1. We're going to go ahead and give it over to Dr. Taylor to get started.
Fantastic. All right, so first disclaimer, the current date and time is Monday, September 9th at 4:30 p.m. The reason why I do that is because I have not looked at any of the exam questions yet. I wrote some, but there's going to be a couple of things that people will likely ask or I'll mention that I won't actually know because the exam is not finished as of right now. So we're definitely still going to talk about a lot of things that will be really useful. But before I forget it, let me say that caveat that it is Monday, September 9th at 4:30 in the afternoon. We're not finished yet. But I did want to cover a couple of things. So one, this will be recorded. Y'all can drop questions in the chat. I'm going to talk about a few things as questions might be coming in. So first of all, I'm going to take a look at some of the things that are in the 701 section. So first of all, hopefully by now y'all have noticed that you've got chemistry on here a couple of times in e-learning. And one of the things that you have is you have not only your individual lecture section, you also have what's called the 701 section. Technically, it's the exam section. We use it anytime there's something that we want everyone to have access to. So that way it's not Dr. Taylor's students and it's not Dr. Diekman's students, it's everybody. So one of the things that everybody has access to is this big red folder that says midterm exams, useful information. And in here is things like the potentially useful information. Now, I already have this set up in my OneNote to make it a little bit larger, but I just wanted to show off this is what will be part of your exam. So on exam day, we will pass out physical exam booklets. And part of that exam booklet will have not only the questions, there will also be 2 pieces of scratch paper at the very, very back. And this is actually also part of the exam. So this is going to be technically before the scratch paper and after the questions, but you'll see it. You'll see it because it's got potentially useful information, a bunch of constants on here. You might not need all of these. That's why it says potentially useful, because you may or may not need them all. It does have equations on here. These are the only things we're going to give y'all equation wise. And then it does also have a periodic table. Now, the one thing I want to mention about this is the one that we're going to print out, but when we print it in black and white. So just be aware that this is not going to be in color on your exam. I know it's in color right here, but we'll basically just print it out in black and white on the actual exam itself. But we will give you a periodic table. The one we're giving you is posted in the 701 section, so that way you'll know exactly what you'll have access to. There is also a list of metric conversions to memorize. So again, still in the 701 section, y'all can find this whenever you want. I'm just clicking through some e-learning things that you already have. It's everything that's highlighted. It's everything that's here in yellow. So whatever the ones that are left are not, but kilo, deci, centi, milli, micro, nano, the angstrom, and pico. So this is the set for y'all to memorize. These are what we're going to say are fair game that we can use on the exam, that we are going to expect are just a way to do science communication. So every once in a while, there will be something that is basically scientific communication. We expect y'all to know what that is so that we can just say it. You know what it is. We're not going to give those to you. And the last thing in here is some details about the exam. This is some of the things that for the very first exam are really nice, especially to go over. The fact that the format is multiple choice with usually 2 short answers at the back. 2 short answers is what we aim for. It's what we've managed to do so far for the past 2 years. I'm keep kind of throwing my hands up because there's always a chance that we will do something slightly different, but a very, very small number, like 2, is a really nice number for us because we have to grade all of them. We'll give you an exam booklet. We'll give you a Scantron. So since a lot of it's multiple choice, you guys are going to have a bubble sheet to fill in. We will give those to you. Periodic table, the constants, which is those pages I just showed off. You are going to bring a calculator. Number 2 pencils, can be mechanical. Your UTD ID, so that thing that has a photo ID of you, could be a different official photo ID. We need your 10-digit student ID number as part of what you're going to fill out on the Scantron, and that's the reason why we want you guys to bring your UTD ID instead of like a passport or your driver's license, because that way, also everybody has one of these. Everybody's got a UTD ID comment card, so that's what we're talking about there. You also have to know your metric conversions. List of things not allowed. The instruction cards for the calculators, I don't even know if I have. Oh, I do. I know my image is really, really small, but it's this silly little thing that's a little piece of paper, and I can actually flip this out if I really wanted to. You might notice that it's got lots of really small writing on it, and having a little piece of paper with lots of really small writing on it makes the proctors nervous. We don't like it. So one of the easiest things to actually do is to just, whatever this little cover sheet is to just leave the cover sheet in your backpack or at home, and just have your calculator. Is usually what's actually easiest, because that way you don't have to worry about that. Yeah, a lot of calculators come with little instruction cards. Food, that's mostly honestly because can I imitate the crinkly sounds? Crinkly sounds are annoying. So we try to cut down on crinkle noises during the exam, because everyone would like a nice quiet atmosphere. No books, notes, or formula sheets. We will give you everything, and basically nothing that connects to the internet. You're supposed to use your own brains, so anything that connects to the internet is a no. We do have room assignments now. Room assignments. So let me make this a little bit bigger. So we do have room assignments. They're up, they're posted, they're in places. These are fantastic. They're great. We're all across campus. We're in a whole bunch of different rooms. So please do go check out your room, wherever that may be, because we are in lots of buildings. Lots and lots and lots of buildings. I will not count them right now. I'm curious. I don't remember how many buildings we're actually in on campus. It's a lot of buildings. So just be aware, check out your building in advance. For those of y'all with ARC accommodations, I sent y'all an email last week. This is actually a different room from what I sent y'all last week. We put you in a bigger room to make sure that you guys would have quiet space and enough elbow room in between all of y'all. So we actually changed the ARC room from last week, which we'll get another email from me soon. Yeah, so short answer, usually 2 of those. Short answer questions, we aim on short answer. We aim for, again, I haven't finished it yet. We aim for 1 calculation and 1 non-calculation. That does not always happen, but that's what we aim for. That's what we try to do, just because that way some folks are better at calculations, some folks are better at other things. So we try to do 1 of each. Again, it does not always happen, but that's what we aim for. That's what we try. One of the other questions I got was for general study tips. I know that's probably too small for y'all to read, and that's okay. I got another call for general study tips. So a couple of things. One is hanging out. It says the end of chapter questions and keys. So y'all are already doing Alex. So one of the pieces of advice that I have for you is as you're doing Alex is useful, but consider what is important. And what I mean by that is sometimes people will do Alex and they'll come out of an Alex question and be like, that was useless. I don't see how that's useful at all. And I promise you, Dr. Diekman and I have gone through every single Alex question, all of them that are assigned. We picked them all. And I can tell you the reason we picked every single one of those. So if you don't know why that was in there, ask Ask me, ask Dr. Diekman, ask Dr. Enka, because it's in there for a reason, I promise. So everything in Alex is in there for a reason. We actually trim those down so that it's a small, manageable number. That was what the goal is. And then to get more practice, I also really like the end of chapter questions. End of chapter questions. There are a lot of these. So there is a selection in the 701 section so that you're not doing all of them, because there are over 100 at the end of every chapter, and that's a lot. And time is a precious resource. So we have some selected ones out of chapter 1, chapter 2, chapter 3, and chapter 4, just so that y'all don't have to do all of them. That being said, if you get to I don't even know what this is, but number 16 in chapter 4, you might look around and be like, I really like some more of these. So maybe you actually want to do 14 and 18. Maybe you want to look around because oftentimes there's more questions nearby it that are similar to it. So if you do want more, you can definitely do more, but we have kind of a selection to help y'all get a variety of questions. That's that. So you guys are doing Alex. Think about why it's in there, in the chapter questions, and the old exam. You guys have the fall 23. So I'm going to show you where that is. I'm still in the 701 section. Wouldn't you know it? And I know that a lot of this is likely duplicated in some of y'all's individual sections, but this way y'all can see it in the 701 section where everybody has access to it, and we don't have to play the game of it's somewhere in Dr. Taylor's section. No, everybody has these examples of exam blanks and keys. So we post the blanks so that y'all can take a look at some of these questions and go ahead and try these. And you can just go ahead and sit down and take this exam as if it was an actual exam and just see how you do. But there's 28 multiple choice questions on this one and 2 short answer. Shrugs. So that was what we did last year. Now, the other thing I like about this is it does have the general instructions on it, which I know most people don't read, but they're there. So for those of you that want to be like, what's it going to be like? What are you going to tell us to do? The general instructions on the front of the exam booklet are basically what the TA announcements always are. You can ask questions during the exam, by the way. You could ask whatever you want. Worst case scenario is the TA looks at you, smiles, and says, do your best. But that's all on there. Okay. Wrong thing. Right thing. There we go. So I do like those 3 resources. And really, this is all to try to figure out, notice what you know, what you guess, and don't know. So a lot of times when I talk to y'all, I may ask you a short question and the response is sometimes an immediate, and I'll ask something like, so what is the letter associated with an L value of 0? And either the person responds with S, obviously it could only be when L equals 0, that means S. But sometimes you look at me and you say something like S, and your voice goes up at the end and you're kind of asking me back, I think it's S, but I'm not sure. And other times you look at me and say, I really don't know. I don't got this. So keep in mind that all 3 of these options, what you know, what you guess, and what you don't know, they're all options, and part of your job as students is to notice where you are, is to notice what do you know, what are you you're kind of okay on, but maybe not 100%. And then what are you really guessing at? And you're just I don't even know what that is. I don't know where to start. So all of those pieces are important. And that can also help kind of guide your studying, because if you know something, then you might try to still ask yourself questions about it to make sure of that. But especially in these other two cases, you may want to spend some more time on those particular sections. Other things that I know about your exam that are useful, it's 80 minutes long. 80 minutes. Your proctors will be in charge of that, but that way when you're looking at the old exam, you know that that's supposed to be done in 80 minutes. Basically what happens is the exams get passed out. There's a cover sheet on it. After everybody's got one and all the information's filled out, name, all that jazz, then the proctors will say, any more questions? You may begin. And that's when they hit go on the timer. But it does include bubbling in your answer choices on that Scantron. So 80 minutes, including bubbling in your answer choices on your Scantron. You got to bubble in your Scantron in those 80 minutes in pencil. Yes, you do. Okay, I think that's all my generic advice for right now. Are there any questions from the chat yet? Do we have people watching the chat?
We do. 1 second.
No worries.
I mean, I can read it out for now, since, but okay. First question we have is, do we have to write the short answer questions in a specific format?
Okay, what else?
If we keep our comment card in our wallet when we walk in, should we leave our wallet behind,
Okay.
Is there partial credit?
Okay.
By how many significant figures do we round if there are any in short answer calculation question?
Okay. Other things?
Oh, sorry.
Mm-hmm.
Will the individual questions tell us how many significant digits, like in Alex?
Okay.
And this should be the last one. Is there a separate key where the answers to exam 1 are worked out instead of just the right answer choice?
Cool.
Yeah, okay, that should be it for now.
Great. Okay, so as far as a short answer format, basically this is the part where the goal is to read the question. And this is again why I like to point out that we have the old exam posted. Read the question, read all of the question, because it will also say things like, it usually says something like, give 3 digits, because we don't actually test y'all on significant figures. So we usually just ask you for 3 digits. That's mostly so that you don't just tell me that the answer is like 100 and I don't know what that means or what that is. That way you can tell me like, and I don't know how exact it is, and that way you can tell me like, no, the answer is like 125. So, and you don't try to blame me later to tell me that you just rounded down. So we will usually tell you to give us a certain number of digits in there, is usually how that one is worded. Partial credit, yes, that's the whole point of that. Do also watch the instructions, or watch some of the keys that we've done before, because usually the right answer needs work to be worth all the points, especially if it's a calculation. Needs work for full credit. Especially if a calculation. Sometimes if it's not a calculation question, sometimes there is no way to show your work. But if it's a calculation question, then showing your work is part of the answer. And we will absolutely dock points if the only thing that's there is the number and nothing else. Question is about the comment card in your wallet. So this is really kind of one of those weird things. This one kind of depends on how much stuff you want on your desk at one time. You're welcome to put your wallet in your pocket. If it fits in your pocket, you can put it in your bag. You can leave it at home. You can leave it wherever that works. You can actually leave it on your desk if you want to. We just need your comment card. So I've definitely had folks, I don't actually have one at the moment where your comment card is actually like, there's a clear part of your wallet and your comment card like shows through your wallet. Those folks just usually like leave it on the desk and just leave it there. And then your whole wallet's on your desk, but like you can see it. We're not going to take it away from you. We're just going to double check that the picture and the name match. So as long as we can see, because really what we're doing is we're usually making sure that the picture on the ID matches you. I become obsessed with people's noses, by the way, when I do that, because y'all's hair changes a bunch. So we're usually matching the picture from the ID to your face, and then we're also double checking that the name on the ID matches what you wrote on your Scantron. So that's the things that we're checking for. So wallet on the desk works just fine. Is there a separate key for exam 1? I never get around to this. I always mean to, and I don't manage it. So the question was, is there a separate key for exam 1 with answer choices with the work already written out? There is not. So one thing that you can do is if you know that there are questions from exam 1 that you don't know how to do, you can actually ask me. You can actually drop that in the chat. Now, I'm going to warn you what I'm going to do with that, because some of y'all have not gotten to take a look at the old exam yet. And so I will actually make a follow-up video with the extra questions. And I put all the old exam questions, any that people ask me, in there. Any fall 23 exam questions go in the follow-up video automatically, just because if you do want to go ahead and sit down and take that like an exam and you've already either slotted off time either tomorrow or Thursday for that, then I don't basically want to spoil the exam for you. So that way you can still have that as a tool to use for your own self-assessment. So basically what I do is we'll keep taking questions out of the chat. I'll go ahead and do a little bit more just because I just talked with those folks. I'm going to wait until 5 o'clock to ask for more questions, to ask our wonderful, fabulous moderators. But basically anything that's just a general question, I'll answer. Anything that's an old exam question, I'll do in the follow-up video. If there's more questions, then I make the follow-up video and I still put those exam questions at the end of the video. And I'll like warn you guys so that, spoilers basically is what I'm doing. Spoiler alerts. Okay, so something I'm going to go ahead and chit chat about just because it's something that I was getting some questions about from my various students. It was actually, so when we do quantum numbers, I got 2 questions that showed up a lot. One of them is basically, how does L depend on N? And this is kind of an interesting question because the odd thing about these is, on one hand, L does depend on N, and that's real. So remembering that N is a principal quantum number, and so N is things like 1, 2, 3, all the way to infinity. And L depends on N. So L starts at 0 and goes all the way to N minus 1. The thing with L and its connection there, though, is essentially N tells you, let me write this down first. N tells you how many values of L there are. So what I mean by that is when N is equal to 2, then I have 2 values of L. I have L equals 0 and I have L equals 1. When N is equal to 4, then I have 4 values of L. I have L equals 0, and L equals 1, and L equals 2, and L equals 3. So no matter what the value of N is, I have that many values of L. Keeping in mind that values of N are called shells and values of L are called subshells. So my value of N also tells me how many subshells I have. So I could also talk about these as when L is 0 and N is 2, that's the 2s subshell. When N is 2 and L is 1, I have the 2p subshell. So, and then here in green, I would have the 4s, the 4p, the 4d, and the 4f subshell. So N and L oftentimes go together because together they describe a subshell that has both a principal quantum number, or our shell number, and it also has a subshell letter, in this case, S, P, D, F, and technically you can keep going, G, H, I, J, K, all the way. So these things all build on top of each other. The other direct question I got asked is I also got asked, how do you know if M sub S is positive or negative? So I am skipping over M sub L for now. I expect some questions on it. So M sub S is spin. It's either positive 1/2 or it's negative 1/2. Those are your two options for spin. We have a tendency to represent those as up arrows or down arrows. That's my little 1s orbital. The thing is that the very short answer for how do you know is usually you don't. Let me spell that. Usually you don't know. Now there is as always an exception. I could tell you things. So for example, I could go ahead and say that that I would like the quantum numbers for the circled electron, and I could tell you that the other arrows have a spin value of positive 1/2. And what I'm looking for is the questions asking me, what are the quantum numbers of the highlighted arrow based on this information, which I understand is hand drawn, so it's not great, but I can actually do this. I have a value of 3, which is my value of N. I have D, so D means that L is equal to 2. Then, this is a tricky one, I don't really have my M sub L values. I understand that for me, I'm just going to be like, -1, 0, +1. This is where, if this was a short answer question, we would actually accept any, wait, I did D. I didn't finish, no. There, D. I'm not tired, I am tired. Sorry. D subshell should have 5 blanks. Everything else is fine though. They can just be empty. There's no electrons in the rest of the 3D subshell. There's just 3 of them in there. So I would also need, so actually this is a great example because now watch me go +2, -2. Woo! I understand that usually when I'm doing the 3D subshell, I would absolutely go -2, -1, 0, +1, +2. This is that weird time where all of my orbitals are of equal energy. So you don't actually know which m sub l value this is either. You would just have to tell me one that's valid. So really, any value of m sub l would be valid for that electron, as long as it's valid for my subshell. That's the only thing that matters. So I have 5 different options technically for my value of m sub l. Any of them are correct. Now in this case, because I went ahead and in the problem went ahead and said we're gonna say that you have information on m sub s. We're gonna say you have information on m sub s. That means that since this highlighted electron has to have the same spin as the other electrons, you therefore know what the spin is. But that's actually the only way that you would know. So this answer would be 3, 2, and then we'll just go ahead and pick 1, keeping in mind that because if this was a short answer, this could in fact be -2, -1, 0, +1, or +2. Any of those would be correct. But since we're going to assume you had information about spin, we're going to go with +1/2 as the correct answer. Normally, though, if you don't have any information about spin, about some other electron, you have no way to know that. So the thing that could be true if the question didn't give you information about spin, you just have to check to make sure that spin is either +1/2 or -1/2. And then in that case, you just have to keep track of like m sub s is not 0. M sub s is not 1. A lot of times those are the kinds of values we put in for spin to try to throw you guys off, because that way we're like, I mean, you know, they're small numbers. They look reasonable, but spin has to be +1/2 or -1/2. So for those of you that, I really think I oftentimes get asked more questions about spin, because after dealing with N and L and M sub L, it just seems like M sub S is too simple. And actually it actually is pretty simple. It just kind of seems like it ought to be more complicated because M sub L and L get kind of complicated. But M sub S, there's only 2 options, +1/2 or -1/2. And the only way you'd know is if you had other information about it. It's the only way that you'd know. Otherwise, it's only 1 of 2 options, and as long as it's one of those, it's fine. Okay. It has not been very long, but I'm going to try to, I'm usually bad at this. I'm going to try to ask for questions every like half hour or so. So are there any questions so far? More questions?
Yeah, we got quite a few.
Cool. What we got?
So the first one that we have is, can you explain the difference between shells and orbitals?
Okay.
Can you explain diamagnetic elements in their neutral ground state?
Yes. Okay.
Could you go over finding ionization energy and atomic radius energy and its difference?
Okay.
Could you go over Bohr's model, hydrogen atom model, line spectrum, isotopes, increasing electron affinity, and the quantum mechanical model of the hydrogen atom?
I missed something in there. I tried really hard. What came after isotope?
Isotopes, increasing electron affinity.
Got it. Like I even knew where I lost it. Okay.
And the quantum mechanical model of the hydrogen atom.
Yeah.
And could you explain molar mass conversions, not conversations? Let's see. When drawing the graph for the d orbitals, does the value of ml affect which plane the graph is drawn on?
Okay.
And for this quantum number question, couldn't we use the 2I or L plus 1 formula to find the number of values for m sub L? I can't tell if that's an
Okay.
I or an L.
No, no worries.
And then can you cover how to draw the different orbitals?
Ooh. Anything else right now?
No, I think that's it for right now.
Okay, cool. All right. So I'm going to I'm going to hop all around these. I'm going to do my best. And this is the reason why there's a follow-up video, by the way, because if I can't get through all of these, and we'll still keep taking questions, then I just make another follow-up video afterwards. Okay, shells versus orbitals. This is actually a really good question. And that's so if I looked excited, there's a reason. So here's the game. And honest to goodness, it's a game. So shell is for my value of n. Subshell is for my value of L. Orbital is for my number of values or for my value of m sub L. Now, let me give you a different example before I go over the one in red. If n is equal to 2, I have 2 subshells, L of 0 and L of 1. And when L is equal to 0, I have one value of m sub L. When L, 0, one value of m sub L, which is 0. When L is 1, I have 3 values of m sub L, -1, 0, and +1. So here's the reason why I have a couple things up here. If I'm doing the 2p, so L is 1, that's p. So if I'm going this way, then I have 2 and p, and why am I only drawing one blank? Lots of blanks, 3 blanks. Then I've got the 2p subshell, which has 3 orbitals in it. So, but the 2 shell has the 2s and the 2p. Oh gosh, I got to draw that one more time. Sorry. This has to be lower in energy to make me happy. 2s. So here's the game. This whole thing is the 2s, is the 2. Sorry. I'm going to take a drink for just a minute. This is. Okay. This is the n equals 2 shell. It has 2 subshells. It has technically 4 orbitals, which is each blank line. So my orbitals are, this is an orbital, that's an orbital, that's an orbital, that's an orbital. 4 orbitals total in that box. So that's shell, subshell, orbitals. Now, the reason why, 1, I'm taking a deep breath, and 2, I was excited about the question is because we always start at the lowest energy possible. At the lowest energy possible, that's actually going to be this value of n equals 1. When n equals 1, I only have one subshell in n equals 1, which is the s subshell. And for the s subshell, I only have one orbital. So the bizarre part here is this box here on the left is the n equals 1 shell that only has one subshell that only has one orbital in it. So oftentimes it is honestly confusing because since, especially when we're doing orbital notation, we have a tendency to start from the beginning. So we talk about the 1s, and that 1s, technically, every time we say 1s, we really ought to say the 1s subshell or the one orbital in the 1s subshell. But honestly, we get lazy and we just say the 1s orbital because technically that's also correct because there's only one of them. So there really is a difference. But if you heard the 2s orbital, that happens because every time we have an s subshell, the s subshell only has one orbital in it. So taking a bigger, broader look, the larger your value of n, the easier it is to differentiate between a lot of those, because even once we get to 2, now I've got 2 different subshells, and at least one of those subshells has multiple orbitals in it. So can be done, but because we usually start low, they collapse a bit, and then we start to get them as they go higher. So that's dealing with that difference between shells and orbitals. So many things. Somebody asked, and this was, I think, just trying to relate to the question we just did, but I didn't ask quite the right question. Is for the quantum number question, can we use a formula to find the number of values for m sub l? So this is a game, because if the question is if L is equal to 2, what are all the values of m sub L? Notice it says all the values. This question is different from something that's going to read very similar. If L equals 2, how many values of m sub L are there? So these two questions are actually different. So the top one asks for the values of m sub L. When L is equal to 2, m sub L, you start at negative L. So that's negative 2, and you go all the way to 0, and then you go all the way to positive L. So positive, so that's positive 2 in this case. So all the way from negative L to 0, all the way to positive L. So here are all the values of m sub L. So that's one question that can be asked. And that was kind of what we were grappling with in that other question. I needed a value when we were over here and doing quantum numbers. I needed a value of m sub L that was true for that value of L. So that's one question. The second question below it is actually a different question. It asks, if as L is equal to 2, how many values of m sub L are there? Now, because we've already written them out above, you could just count them. 1, 2, 3, 4, 5. And so you could tell me that there are 5 values of m sub L. But this question is actually where that comment and that formula comes in, where I could take 2 times L plus 1. So I could take 2 times 2 plus 1 to equal 5 and tell you that there are 5 values of m sub L. So that little equation does work under the right circumstances. You might notice that that formula is not given on your formula sheet, which essentially means we're going to keep our values of m sub L low enough that you could always just write them out and count them. Some people really like the formula. If you really like the formula, then you'll have to memorize it because we're not going to give you that one. But again, we tend to keep our values of L and M sub L low enough that should you actually need that, you could write them all out and count them if you needed to. Yeah, those are two different questions. Big cheesy smile, because this is part of the reason I warned my classes and I was like, quantum numbers are actually not my favorite topic. I can talk about them a lot, but honestly, even this fact just kind of annoys me because those two questions sound really similar. They've got most of the same words in them, but they're different. And so quantum numbers just, it's really not my favorite topic, honestly, because of things like this. But ironically, because it annoys me, I tend to keep track of some of those differences. So good news, because it irritates me, I'm very well aware of some of those problems. Okay, so we explained shells versus subshells, and we talked about the use of that formula in M sub L with that previous one. Since we are talking about orbitals, let's go ahead and deal with these two. So let me go ahead and talk about how to draw orbitals, and that'll actually answer this top question too. So when we're talking about how to draw orbitals, and so that's all the other reason why I wanted to make sure we had this conversation before we talk about how to draw orbitals. So we need that first. So when we talk about how to draw orbitals, there are things like when L equals 0, which is our S, and that only has one value of M sub L, which is 0. And the nice thing about this is just a sphere. So even though we could go ahead and put this and put an X here and a Y here and draw it, that's S. It's a sphere. A circle is as good as we're going to get for that. I didn't even draw a very good circle, but it's supposed to be a circle. That's fine. That's great. That's S. You might also notice that it only has one value of M sub L. It's also a sphere, so no matter how many times I try to rotate it around, there's really only one orientation for that. My next ones get a little bit more interesting. When L equals 1, this is going to be P. And I've got 3 different values of M sub L, which tells me I have 3 different orientations to worry about. So I'm going to go ahead and draw my axis the way that makes me happy, which is X over there and Y up there. I am going to change this once just because the Z axis, I'm going to put Z over there and Y over there. Yeah, that's the way I'm going to do that because that's going to make my life easier. So I should have a PX, a PY, and a PZ orbital. My PX is just going to be centered on the x-axis, like that. That's my PX. My PY, centered on the y. Yeah, I'm basically drawing a figure 8. PZ should be on the Z orbital. You can also get fancier and draw them as like the two, sorry, and draw them as basically two circles that are supposed to be the same size but have a little gap in between them. All of these are fine. About the only thing that I would say is a problem. So I've got 3 different orientations. I did have to draw my Z over here just to make my life easier. If you were better than me and you want to be like, this is my Z axis and there's my Z, also read the instructions on the question. We usually try to aim for something that's a little bit easier for us to evaluate. So we have a tendency to go with these ones up above. So just notice that things that we would be worried about, actually, let me rephrase this. Things that might miss points. Things that might miss points is if it's like really off, like something like this and something like that. Something like this might not give you full credit because that definitely seems more like you're trying to build me a snowman than you're trying to give me like either a figure eight or like two pieces that are the same size. That's a little worrisome. So one of the things that does happen when we are grading short answer is there are judgment calls that have to be made. But a lot of times if we are going to say, I don't think this is good enough, or even like, I think this is good enough, but this is kind of weird. What actually happens is either we take a picture of it and we send it to the other instructors, or we email the other instructors with like a little note or description, and we'd be like, hey, this is supposed to be worth 3 points. It seems like they kind of have the right idea, but something is definitely wrong. I think this should be worth 1 point out of 3. What do you guys think? And we basically get a consensus among the instructors before we assign it credit. That way, even if something's really weird, all 1,500 students get the same evaluation. All 1,500 students should ideally get the same number of points for the same thing. That being said, y'all are always welcome to look at the back of your Scantrons. We will keep those, but you guys can always ask for them and we will give them back to you one way or the other so that you can see how you were graded, because it's your exam. You're allowed to do that. You should check with your instructor to see how timely they want that to be. I personally will be double checking the syllabus to see what our time limit is on that, just because I feel guilty if I can't do that when y'all ask, and sometimes y'all ask me back for exam 1 in December, and I get a lot of requests in December that make me sad, because I can only do so many things in December, because we don't have that many days of class. I know it's December, right now it's September, you guys don't care. So I did P, okay, so we've done S, and we've done P, and there's one more set that y'all are responsible for, which is D. So I have to admit, I'm going to double check myself on here because I don't freehand D super well. So this is going to be when L is equal to 2. These are going to be D orbitals, M sub L. I've got 5 options, so I should have 5 different D orbitals. Now, something you actually could notice up here is I just said, hey, I have 3 values of M sub L, and I've got 3 of these. And I didn't actually connect which one of these is which. That's because we do expect you to know that PX is on the x-axis and PY is on the y-axis and PZ is on the z-axis. That's enough. That's plenty. Technically, yes, each one of these does correspond to a particular value of M sub L. That's a true statement. We are not going to make y'all memorize that. So we are not going to have y'all know that the PX is a M sub L value of -1. Don't have to know that. I know that might seem like an arbitrary boundary when we are going fairly detailed, but that's where our boundary is. So yes, every value of M sub L does relate to one specific orientation, but you don't have to know which one is which. You don't have to know that PX is M sub L equals -1. I'm actually not certain if that's the correct one because I don't have that memorized. So yes, they do relate. No, you don't have to know that, to know which one's which. Okay, this is the one where I am going to double check just because I think I can do it, but I am not entirely positive, and I would like to get it right because aside from that, the DZ squared is the donut one. That's the only one I know right now. Oh yeah, okay. So one, I'm going to flip-flop these orientations around to make my life easier. Also to make me not have to go back and forth. I'm going to flip this over as my personal, like, did I get it right? Because it's being recorded. So I want to make sure that I got this for the recording. I forgot to double check. I hope we're recording. Otherwise I sense more questions. Okay, so I'm going to do the donut one first. Because this is the dz squared, and it is the one that I'm like, I know what this one looks like because this is centered on the z-axis. So that's the z-axis. I'm just going to go ahead and draw, I guess, the x-axis here. But the dz squared is the weird shaped one because that's the one that has the two lobes. So it kind of looks like a p orbital, but then you got to throw in the donut. That's the best I can do. I know it looks really weird. I know it does. So the good news here is that if this is the best that I can do and it's not great, realize we have a lot of patience with what yours might look like. Because that just, you got to do your best. Dx squared minus y squared is the one that's actually on the x and y axis. So this is supposed to be a clover leaf now. 4 lobes actually on the x-axis and y-axis, as opposed to, I'm going to draw it underneath, but I want you to be able to see them both. This is going to be x, this is y, this is going to be the dxy. This is just in the xy plane. This one is not actually on the axes, but this is in the plane. So you're basically kind of pretending that there's invisible lines going that way. For those of you that might have covered it, you're basically pretending that the x-axis and the y-axis are the nodes. The x-axis and the y-axis would represent some of your like planar nodes through this thing. If you guys didn't cover planar nodes, they can be helpful for describing things. I covered them because I think that they're helpful to go into a little bit more detail, just for drawing purposes, really, but we don't test on nodes. Okay, now we just have to do all the planes. So this can be x and this can be z. And now I have something that is going to be drawn exactly. Gosh, this is a terrible butterfly. Anyway, this is the dxz. Notice it should look basically just like dxy. It's just in a different plane. So this is now in the xz plane instead of in the xy plane. And I think it's going to look ridiculously similar. We'll go ahead and still call the one up y, I guess, and this one over here z. And now it looks the same because it's basically the same shape. It's just in different planes. And this is now the dyz. So again, the goal is to try to draw the shape, which the shape is supposed to be like a clover leaf. I know y'all draw flowers. Some of y'all draw flowers way better than me. Just, I've seen it. I've seen people draw much better, prettier, wholesome lobes. That's better. So again, we have a lot of patience for folks that are honestly trying, but are maybe a little off. And again, you can kind of imagine that my DXZ is having a bad day, but they look like they're trying to be about the same. They're trying. So again, technically there is a value of M sub L for each one of these orientations, but which one is which, we are not going to hold you accountable for. So yes, technically everyone is one specific one, but no, we're not going to hold you responsible for which one is which. I'm just going to move my little z squared up here to be closer to this guy. Okay. Now I've got to go back to my list, but I am going to ask for more questions after I give myself little happy check marks. graph, we did that one. We also did how to draw orbitals. I got like 4 questions I haven't hit yet. That's okay. I'm gonna draw myself little boxes to remind myself that I didn't do these yet. Are there more questions in the chat so far?
Yes. What do you mean that ML equal 1 could be -2, -1, 0, 1, or 2? If the spin has to be plus or minus 1/2, if the M of is of S, can you explain? Oh, wait. Did we go over molar-mass conversions?
We haven't done it yet. So someone asked about it, but I haven't had time to do it yet.
Yes. In the quantum number set of 4 numbers for M sub L, do we state how many possible M sub L values there are, or a specific M sub L value? Let's see. Do we need to know exact definitions of terms? Sure. Could you go over the emission spectrum?
Okay.
Will we be asked to draw d orbital graphs, or do we just need to know how to identify them to be able to identify them?
Okay.
Will there be questions over electron affinity and ionization? Let's see. How does quantum mechanics explain classical physics' limitation of explaining how electrons transition between orbitals without crossing between them? And could we go over mole conversions and unit conversions? And that's all for the moment.
Okay, cool. Okay, so I'm going to take care of the ones on here that are relatively quick. Can we basically, d orbital drawings, this is basically, can we ask you to draw a d orbital? Yes. I'm just going to say yes. I just drew all 5. I know that some of them looked sad, but I can do it, you can do it. So I'm just going to say yes to this, that's okay. We could just ask you to identify them. That might happen too. But yes, we are allowed to ask you to draw them. We absolutely are. Are there going to be questions on ionization energy and electron affinity? Yes. Those are the last 2 topics that we're going to cover before the exam. So for those of you that are like, but we haven't done that yet in class, yeah, that's because today is Monday and they're the last 2 topics. I will almost certainly cover electron affinity on Friday. Like I hope that I can start ionization energy on Wednesday, but so far, even in my like wildest dreams of speed, I still have to do electron affinity on Friday. I can't. I try real hard, but I can't. Explaining the emission spectra. That's gonna take longer. Do we need to know exact definition of terms? So the hard thing is when you say the exact definition of terms, this can mean a couple different things. So to give you a short answer, I'm going to say yes. Now, here's the reason why I'm like, because when you say knowing an exact definition, sometimes this means memorize with no applications. And that to me is almost useless. Because if you just straight memorize something and you can spit it back out at me in words, but you don't know what they mean, this is not super useful. Now, the reason why I'm like, I would know the exact definitions is actually because when we're doing something like Hund's rule talks about that the goal is to maximize spin. And the difficult thing is there are times where things can look really weird, but knowing that Hund's rule is to maximize spin, and that's all, helps a lot, because we could have something that asks, let's play the game, which of the following is a violation of Hund's rule? And we're going to do a couple of them, so give me a minute. A 1s, 2s. B, this is the 2p, and it looks like that. C, also the 2p, but it looks like that. E, and it looks like this. More ups. More ups. Sorry, I shouldn't get so excited about that. And the question is, which of the following is a violation of Hund's rule? Now, here's the game. We'll go ahead and call this the 2p for funsies. Only one of these is. Only one of these violates Hund's rule. Only one. Everything else, some of these also have things wrong with them, but only one of these violates Hund's rule. The other three maximize spin. So Hund's rule is to maximize spin, and that's all it says. That's the only thing it says. So the thing is that over here, this is a problem, that this is an Aufbau violation. So this does violate what we think of as the build-up principle. The idea that as you're putting in electrons, you start at the lowest energy level and you build up from there, filling in each subshell as you go higher, filling in each subshell before you get to go higher. That's an Aufbau violation. But Hund's rule just says to maximize spin. Both of those are ups. Arrows, both of those have the same spin. According to Hund's rule, there's nothing wrong with A. According to all the rules, there is something wrong with A. But according to just Hund's rule, A looks great. A is fine. So in that same way, D, with all of these up arrows, this is a violation. It's a violation of the Pauli exclusion principle, because there are now multiple electrons in the same orbital with the same spin. And that is not allowed. The Pauli exclusion principle says that every electron has a unique set of quantum numbers. So D is a violation of the Pauli exclusion principle. But oh my gosh, if all we care about is Hund's rule, that's fine. That's a lot of maximized spin. That is maximizing spin to a degree such that we're really not allowed to do that. But we maximize spin in D. That's looking great. To B, there's actually nothing wrong with B. This is actually fine. There's actually nothing wrong with it. The only thing weird about this is we're technically very accustomed to going from left to right, but the weird thing here is each orbital has the same energy, and it doesn't matter which orbitals have one electron in them. All the spins are going in the same direction, so that's good for Hund's rule. Pauli exclusion principle says that they all need their own set of quantum numbers. They do. The Aufbau principle says that you have to completely fill the 2p before you move forward. We don't technically have enough information to really evaluate that, which is unfortunate. But basically, since the 2p is all we have, we're just kind of assuming that the other ones are there. So process elimination, this one violates Hund's rule. And that's because I have one up and one down. It's because this is up and this is down. And that's what's wrong with it. Having this first one blank actually doesn't matter either. But having one up and one down, and that's all I have not maximized spin. Hund's rule says I have to maximize spin. They all need to be going in the same direction until they get paired. So that's actually my only violation of Hund's rule here. So again, that's why the person asking about, do we need to know exact definition of terms? And my instinct is to actually say yes, because that covers this style of question where you need to know what those rules are and exactly what they are. And ironically, what they are not, because there's actually some wiggle room in there, that there's things that we do for orbital notation because English is done from left to right. This course is taught in English, so a lot of times we just go from left to right. I usually put my arrows in with all the up arrows first, and then I put in the down arrows. That doesn't actually matter either. You just have to be consistent. You want to put all the down arrows in first and then do up. Great, fine. So there are principles, and you do need to know what they are, but realize that we're going to do a lot of application in there. We're going to do application work. Okay, so I say that question's answered. And then the folks, so this is asking questions still about my M sub L value. So really this is going to, again, depend on what the question actually asks. So let me see if I can get myself some space here. Sorry, this is me desperately looking for my actual keyboard. I'm going to make this bigger. Actually make this bigger right now. So you guys can actually see it. But basically, if I'm actually typing, I want to get the language correct, so that it's a bit clearer. So this is going to say, for the indicated electron below, give a set of possible quantum numbers. And then we will go ahead and still put it in the 3D, since we've been using that 3D example. Oh, I need to do what I did before. Given that the up arrow, we say it, up arrow, sorry, given that the spin on the other electrons shown is M sub s equals positive 1/2. Subscript. Script. Will you give me my cute little fractiony thing? Nope. Sad face. Nope. Okay, fine. Okay, so this is now my question. So my indicated electron is the one that's highlighted. We have a tendency to like circle stuff. So that way I have information on some of the electrons, but not this one. So because it says give a set of possible quantum numbers, if this is my language, then I need to pick. If this is my language, then I need to pick. And you can pick whatever you want, but I have to choose one option. And again, those options could be -2, -1, 0, +1, +2. But if it says to give you a set of quantum numbers, then I only want one value for n, l, m sub l, and m sub s. And so as long as it's an allowed value, that's okay. But yeah, if this is a short answer question, then you've got to give me something that fits the parameters. I asked for a set of quantum numbers. That's only going to have one value of m sub l, right? It's only one electron. One electron should have one value for m sub s, and one value for m sub l. Sorry, we're talking about m sub l. And I know that we've been talking about this, and like, there's no actual, like, this is just orbital notation. There's really no way to like look me in the eye and be like, obviously that is one value, is one particular value of m sub l, because this is all just representations. And that's the reason why we're okay with, if you want to tell me that that one electron we're pointing to has an m sub l value of -2, cool, great. It's valid for the information you have. And the information, because it's labeled 3D, you gotta have a 3, you gotta have an L of 2, you gotta have those, because that 3D portion's labeled, and then you were already given information about m sub s. So you are locked into the other 3. The other 3 here are locked in place, because I got my 3 here, and my 3 there, and I got my D here, so I got my 2 here, and then I was given information about the other ones, and so that has to match. But that m sub l value, I have enough information to have it be one of 5 options. That's all I have. But yeah, if it says to give a set of possible quantum numbers, you're gonna pick. I know that that's a little scary, but just keep in mind that usually this is a multiple choice question. So usually you're selecting the correct one out of the options. And if not, then you get to pick. And it's, again, as long as it fits, there's only 5 options, but there are 5 options, then just feel the freedom. Feel the freedom to pick a value of m sub l that fits in the parameters. Kind of like you get to wear what shoes you want to lab, as long as they're closed-toed and closed-footed, so that your beautiful, wonderful foot does not get acid on it. You get to pick. There's still parameters on there. It's not like you get to wear sandals, but you do get to choose as long as it fits in the parameters. So it could be other things. M sub l state possible or give a value. If the problem says to give a value, we're going to give a value. Uh-oh. I did not make myself enough notes about what that question means. Uh-oh. So to the wonderful person, or perhaps people who saw the question that involved m sub s being either positive or -1/2, if m sub s something, I lost my train of thought and I lost it. I don't know what this question is anymore. So that is my fault, and I'm very sorry about that. So if whoever wrote this one would either put it back in the chat again, or if the folks maybe have already answered it. So if y'all are happy about m sub s, we can just leave that alone. I'm okay with that too. But otherwise, I did not write all of that one down. So I don't know what it is. So I'm sorry about that one. I got some more. Let's go ahead and do a mole conversion, because I've spent a fair amount of time on quantum numbers and some drawing stuff, and I have not done a conversion yet. So let me go ahead and change gears completely and go ahead and do a grams to moles conversion question. Okay, so back to, I'll make this bigger in just a minute. If a golden ring has, I don't know, they're awfully light, 0.75 grams of gold. Maybe it's not that light. 2 grams of gold in it. How many atoms of gold are in the ring? And I'm going to make this bigger in just a minute. So for those of you being like, it's too small, I can't see it, I know. Yeah. That's great. That's good. So, first of all, to note, we are starting with 2.5 grams. The goal is atoms. So the thing is that there's information that can help us. There is absolutely information that can help us. I did not put, where'd my periodic table go? My periodic table could help me. Where did that go? There it is. There we go. But the periodic table, all of these little things that are going to help us, all these little teeny tiny numbers way down there, what that's going to do is the periodic table, that those numbers down there on the bottom are going to give us one piece of information. That's going to tell me, copy my number correctly, 197, that I have 197.0 grams for every 1 mole. That's what the periodic table is going to tell me. So it does give me information because I have grams right now and I don't want them. So having grams, something in grams, is really helpful. But then I also am going to need something that connects moles to atoms. So that's where I'm actually going to need that potentially useful information page again. Sorry for all the scrolling. And it actually has on here, I'm just going to take a little screenshot. So I'm not actually going to grab the whole shebang. Maybe I should have done that for the gold. Too late. And it's this little piece that just says Avogadro's number. So Avogadro's number, what this is going to do is this is going to basically give us the number of atoms in 1 mole. So if you notice, the mole gets the 1. So there's some wacky number of grams in 1 mole, and then there's a giant lots of atoms in 1 mole. But the mole gets the 1. Mole gets the 1 in either one of these conversions. The mole gets the 1. So now we're some math time. So I am actually getting rid of my periodic table, sadly. Oh, let me just nab the gold thing in case I need it. Bye-bye. Hello. Okay, so from the question, we are starting with 2.75 grams of gold. So I'm going to go ahead and start with 2.75 grams of gold. And then I'm going to use my train tracks. When I use these, I am multiplying across the top. And I'm going to then divide by anything in the bottom. Divide by items in bottom. So because I have grams of gold here, I need grams of gold to be down here because I'm going to divide by my grams of gold to get rid of them. So I need to put my grams of golds down here because I'm going to divide by whatever is in the bottom. So dividing by grams of gold will help me get rid of those. And then that's in 1 mole. And then we can use our other factor also in 1 mole. So again, paying attention to that notion, I've got 1 mole up here. So that means I really want 1 mole down here because I'm going to divide by whatever's down here. So my 1 mole goes down here, but now I want this other thing. So that's going to give me, just move that over there. My 6.022 times 10 to the 23rd atoms. So do notice, this is not the butterfly methods. These are supposed to be tracks or train tracks. So I'm multiplying by everything across the top. I'm going to divide by everything in the bottom. I'm going to take 2.75. I'm going to divide by 197. I'm going to multiply by 6.022 times 10 to the 23rd. And that'll get me 8.41 times 10 to the 21st. Make that a little bit clearer. 21 atoms. So a couple of things to note in here. One of them, again, is I've seen a lot of different ways to write these problems out. So if what you need is to have it a different way so you understand what gets divided by, what gets multiplied by, that's totally fine. That is not a problem at all. But there's just different ways to represent it, and they all work. No problem. But in this case, I am multiplying my 275 by the 6.022 times 10 to the 23rd, and then that gets divided by the 197. So there's a method in here also. Can you also hear me?
Yes, we
Yes.
can, Doctor.
Yay, great. Sorry, my AirPods died, and I don't want to play with my... I forgot I usually use my my headphones for this because my AirPods died. Okay. Yay. So we did at least one conversion. So that included molar mass conversion. Something that I should... No, Microsoft. Okay. Something that I should point out is while I didn't do it, I could have also done this in 2 steps. If I do this in 2 steps, what happens is I can start off going from my grams, and in this case, I'm going to show this off a slightly different way. Because I could have gone ahead and gone from grams to moles first. And I could have gone ahead and shown off that this is 1.0139594 moles of golds. And then I could have done a second step and shown me taking some extra digits so that I don't round too early, moles of golds, and multiplying that times my 1 mole and my 6.022 times 10 to the 23rd atoms. Now that's going to give me the same value, but again, you can always do this in pieces. You can't always do this in a couple of steps. So taking the time to say, all right, I'm going to go from grams to moles and moles to atoms, you can do that too. And again, I'm mostly trying to show you a different way so folks that prefer the fraction viewing can see that a little bit. But same general idea. Same general idea. And she gives the same answer. Yay, same answer. Just checking. Phew. Same answer. Okay. So yeah, stepwise or all in one go, doesn't matter. I've now seen some stuff. So I usually use those railroad tracks because usually they're clear, but I got shown something earlier this semester that means that my railroad tracks will actually look more confusing, which makes me sad. Only because my goal is to communicate clearly, and so now knowing that maybe that is not the clearest method means I need to rethink my communications, which happens. That happens. Okay. Okay. Any new questions to add to our list?
So we were given a sheet called potentially useful information. Will we be allowed to have that paper during the exam? Can you go over the AFUBAO violation? Is it okay to mark up the periodic table provided? Should all work be done on the provided scratch paper? Is that Joy? It's spelled JUYSYTS. How you is that just how you draw it? Oh, never mind. Should the quantum number set always be listed in that order? N, L, M, L, M, S? Can you explain the indicated electron question just a bit more? Can you go over line spectra? What do we need to know about it? If the spin has to be plus or minus 1/2 if the MOFS. Could you go through finding the atom given its mass and number of neutrons?
Wait, say that one more time. What was that last one?
Could you go over the finding the atom given its mass and number of neutrons? And can you go over the definition of quantized and line spectra? Do we have to know nuclear stability, like calculating the density of a nucleus, etc.? And and did you already explain threshold frequency and intensity? Because
I did not.
that was one of the questions as well.
I did not do that.
Okay. And I believe that's it for now.
Cool. Okay. So what am I doing? Okay, so from the top, because some of these are yes, no questions. So potentially useful information. This is going to be part of the exam packet. So you will get a brand new one of those. So we will provide you a brand new potentially useful information page for every single exam, every single one. So I did go ahead and pass those out in my classes, I think last Wednesday. And basically I just did that because that way you can see it, you can hold it, and you can be like, these are the equations. But we'll give you a brand new one. We'll give you a brand new one because trust me, one, not everyone was there that day. Two, I have no idea if Dr. Diekman and Dr. Anka do that or not. And three, even the people that definitely held that in their hand on Wednesday don't have it right now, which is fine. That's all fine. We're going to give you a brand new one in your exam packet. So you just have to bring, where was that list? Course homepage, midterm exam useful information, midterm exam details. I know it's going to be small. Maybe I will blow it up. The items you must bring. The items you must bring. There's only 3 of them. Super short. We actually give you guys a lot of stuff. The only things you have to bring is your calculator, number 2 pencils, and we have extras of those, by the way. So while we don't have like 100 of them, we have like 20. So calculator, pencils, and your UTD ID or other official photo ID. That's all. We'll give you everything else. So potentially useful information. We will give you a brand new one of those. Yes, you're allowed to write on the periodic table. Yes, you get to write all over your exam packet. Write all over it. It's we are going to collect those exam packets back from you, but you can write on them as much as you want. Write them as much as you want. The person asking about scratch paper. So here's the game. We only grade the Scantron. So your final answers have to be on the Scantron. If it's multiple choice, you have to bubble in your answer choice. If it's short answer, your work has to be on the Scantron. I am not digging back through exam booklets for your work. So we have scratch paper. So if you want it, that's fine. But by definition, scratch paper means like extra, not graded. So we have plenty. There will be 2 pieces on your exam booklet. So you can write on the exam booklet. There will be scratch paper on your exam booklet. You can even ask for extra after the exams are passed out. I love y'all, but some of y'all feel like if you don't have like 10 pieces of paper, it's not enough. And if all of you want 10 pieces of paper, we will kill so many trees. We already kill a lot of trees with the amount of paper we use. So, but we do have extra should you run out. But just keep in mind, we only grade the Scantron. So if there is something that you want graded, it goes on the Scantron. And multiple choice has no partial credit. So your multiple choice questions, no partial credit. Short answer, partial credit. So short answer gets partial credit, but no partial credit on multiple choice. That's what happens with Scantron stuffs. I don't know what this means. I wrote it down. I don't know what that is. Are the quantum number sets in order in L, M sub L, M sub S? Yes, we also usually actually try to warn you about that. I meant to put that in there. M sub L, M sub L. Sub L, M sub S. Yes. But we usually try to warn you, remind you. But yes, that is the order they go in. So something I want to remind you guys, because if you haven't noticed, I keep dodging this question. So I keep dodging questions about the line spectra. I'm going to put that in a follow-up video, but I want to show you something else. So 701 section, I'm still here. There is pre-recorded lecture videos from 2020. And in here, is it going to make me log in? Oh, it's going to make me log in. It would make you log in too, if it makes you feel any better. Oh, sorry, I changed my password. So we'll see if I remember it. Yay! Seriously, Duo? Anyway, but these have bunches and bunches of lectures. So for those of you that are like, I just really desperately want to hear about quantized energy again, granted, you got to click on these and find it where it goes. But these are just old lectures from 2020. So for those of you that just really want to hear about quantized energy, you really want to hear about line spectra again. 1, yes, I will do it in a follow-up video because I'm gonna run out of time. But 2, these lectures are here. You got to sign in, which is annoying, but they are here for you if you would like them. Okay, this says, what is the spin plus 1/2 or minus 1/2 if given a certain m sub l value, I think is what this says. If this definitely says if the m sub l value ... You're thinking too hard about spin. Spin is plus 1/2 or minus 1/2. And the only way to know is if you already have other information. If it's just an electron, could be either. Could be positive or negative. And then we're back to just pick one. So spin can be positive 1/2 or spin can be negative 1/2. Usually you don't have enough information to know which one is which. I know that that's frustrating, which is part of the reason why y'all keep asking questions about it. But usually you can't know which one it is. The few times you can know is if you have information about other electrons. So all the questions that just ask you if a certain quantum number set is valid, no way to know. So as long as spin is positive 1/2 or negative 1/2, you're good to go. So I think, so spin really is just two options, and unless you have other information, you don't know which one it is. So you just have to go with, it's definitely one of those two numbers. And as long as it's one of those two numbers, then you're okay and it's good. Yeah, it's not something you get to know. It's not something that we can know for sure. Do we need to know nuclear stability? No. We save nuclear stability for Chem 1312, which I know sounds really weird, but we save nuclear stability for nuclear chemistry, which is chapter 20. I actually think it's super fun, by the way, but we don't do it in Gen Chem 1, we do it in Gen Chem 2 with nuclear chemistry. But I do think it's fun. So, not on the exam. Threshold frequencies. Threshold frequencies relate to the photoelectric effect. Because what a threshold frequency is a threshold frequency is trying to ask, if I have an electron in an atom, what do I need? How much energy do I have to get that electron to leave the atom? So I need energy to come in so that my electron completely leaves the atom. It's out of there. That's what a threshold frequency is. How much energy do I need to get that electron to leave? Bye-bye, leave, out of there. This is part of the photoelectric effect. The reason why I told you it's part of the photoelectric effect is because we can only test on something if all the instructors covered it. I took it out this year. I'm having some regrets because I really like the photoelectric effect. But honestly, because I really like the photoelectric effect, I usually take like half a class period for photoelectric effect, and we don't test on the photoelectric effect. So I decided it was not the best use of class time. It was painful if you can't tell. It's like, I think it's really fun. But we don't test on it. So anyway, so that's what it is, but you don't need to know it. So we talked about it. I've got 15 minutes. Oh, we wanted to go back and talk about that indicated electron question again, because it's given some sadness. Okay. For the indicated electron below, give a set of possible quantum numbers given that the spin on the other electron shown is m sub s is positive 1/2. So here's the thing. erasing some things. So, oh, I erased too many things already. Hold on. One moment, please. So this is part of the question. So everything in the box is given. Everything in the box is given information. I should also have given that the possible set of quantum numbers should be in this order, because those of you asking, we do usually give you guys that order to remind you and to tell you that that's what we want. So since that's my order, I should want to find a value of n. Given all the stuff in the box, my n should be equal to 3. So whenever it says 3D, that 3 is my value of n. That's what it is. So no matter if it's an electron configuration, or it's an orbital notation, or it's in quantum numbers, that big number 3 is your principal quantum number. Next up tells me I'm looking for L. L has a set of numbers and letters. So when L is equal to 0, we call that S. When L is equal to 1, we call that P. When L is equal to 2, we call it D. When L is equal to 3, we call it F. Technically, we can keep going. F, A, B, C, no joke, E, F, G, H, I. L is equal to 5. L is equal to 6. But again, so for everything that I have here, I have D, so I know that L is equal to 2. Yes, I did have to sing the alphabet song to know what came after F. This is what happens when I do chemistry for a certain number of hours. Just need some help here. So that's how I knew that L is equal to 2. Then I'm going to, then because, so I got my 3, I've got my 2, then because I know that L is equal to 2, because we figured that out, M sub L could be -2, -1, 0, +1, or +2. Now, the thing is, it told me to just give one set of quantum numbers. So I have to choose one of these. And it does not matter which one you pick. If this is a multiple choice question, then it has to be one of these. It can't be something different. But any of those work. Any of those is a correct answer. I'm going to go ahead and finish in sub s, and then I'm going to come back to this idea. So m sub s here, it's told you that the other spins are +1/2, thanks to both the fact that these are up arrows and this is an up arrow. Also, we are thinking a little bit about Hund's rule here. We're going to say that this is the same. So, but that is why it says here that that's what it is, because technically it should give you that confirmation of what an up arrow represents. So these two arrows here are +1/2. Since this is also an up arrow, it's also +1/2, which is why I know what that is. It's the only reason I know what m sub s is because I had information about the other electrons shown. The only way I knew what the m sub s value was is because there were other electrons shown. The only way that I knew what m sub s is was because I had information about other electrons. That's the only way I knew. It's the only way. Without that, I don't have enough information. So I said I was going to come back to this. So here's the thing. If this is a short answer question, then the key as a short answer question is going to say acceptable answers. And there's going to be 5 of them. And I'm just going to write them all out because me telling you verbally has not worked so far. But notice that the only thing changing is my M sub L value, because everything else is stuck. Everything else is set. You were told it was the 3D orbital, and I therefore have to have 3 for my principal quantum number and 2 for my value of L. And I have enough information about spin that I have to have a positive 1/2 value for spin. So any of those 5 options would be correct. If it says to just give one possible option, then any of these options are correct. For those of you that want to ask things like, what if I give you all 5 of them? The thing you have to realize is the more things you give me, the more things I get to grade. The more things you give me to grade, the more possibility something's wrong. So I would recommend following the instructions in the problem. I recommend that sometime before Saturday, today is Monday, so before Saturday, and I would even say, I'd actually do this before Friday. I would actually schedule this to do the latest to do this Thursday afternoon. I know that there's still some content that will get covered on Friday. I'm still going to cover content on Friday. I won't have finished electron affinity. So I understand that Thursday afternoon or Thursday morning, whatever your schedule allows, but I would go over that old exam Thursday at the latest. You want to do it earlier or you already did it? Good, fine, no problems. But look at how the short answer questions are worded. We are very specific in that wording so that the instructions are clear. There's a surprising amount of instructions because we try to answer all the questions you might have about what we're looking for so that the instructions are clear. So take a look, but do look at the old exam because it's going to help with this. Okay. I'm looking at the time because my stomach is like, we have not had dinner. I'm like, I know, stomach, I know. Emission spectrum, I haven't done. Quantum mechanics stuff, I haven't done. The Aufbau violation, I got 7 minutes left. Don't forget dissipity. Indicate electron question, dunsies. Aufbau question. Aufbau question? I wrote it down. Aufbau violation. Aufbau violation. Did do an Aufbau violation. Did I? Oh, kind of. Okay. So Aufbau violation. So the A that is circled is an Aufbau violation. Aufbau violation because we are violating the build-up principle. There's lots of different ways to demonstrate an Aufbau violation. Those can, but anytime you want to talk about Aufbau, especially a violation, one of the things that you have to have is multiple subshells. Because part of the game of an Aufbau violation is that Aufbau is all about 1s, 2s, 2p, and going in order and staying in order. 3, 3. I guess if I want to do a violation, I could just skip it. So again, if I want an Aufbau violation, I could just do that and skip the 3s. And now I have an Aufbau violation. So anything that either does not completely fill something, so that's why my previous example just had 1s and 2s, because then essentially what I was doing is I didn't completely fill something before I moved on. I had it half filled. In this case, I just completely skipped something. So anytime that we are not completely filling in a subshell before we move on to the next thing is an alphabet violation. Okay. I'm pretty confident someone put this one back in the chat. Thank you for that, because I needed that. Emission spectra. Okay. Alphabet violation. Did that. Line spectra. Finding the atom given the mass and the neutron. I think I can actually do that one in the 4 minutes I've got. I do, however, need a periodic table. What happens if I paste this? Yes, the periodic table. Great. Because I'm going to need that. So a lot of times this looks something like this. We don't give an element symbol. So it'll say something like what symbol is the A, or does the A represent? This is the reason you can tell that I can tell that I'm getting hungry as I'm starting to leave letters out. And we're going to give this a 21 here and a 10 here. So the thing you need to know, and actually one of the things that might help you is this actually will tell you that the atomic number, where the atomic number is on the periodic table. We theoretically should get rid of this middle thing for you. We don't. We just leave it there. So the thing that is useful to know here then is that this bottom number here is my atomic number. Which means this is my number of protons. So from this information, this number up top is my number of protons plus neutrons. So I could just take 21, which should be equal to my protons plus neutrons. So that's equal to 10 plus my neutrons. And I could subtract then, and I could find my number of neutrons. Ta-da! But in this case, since I had the atomic number, I didn't actually have to do that. This just asked me what the symbol is. So I know my atomic number is 10. I'm going to come over. These are in order. And I could just find 10 right here and know that this is supposed to be neon. Now, I think what the person was asking was actually something slightly different. So let me try my hand at this one more time. Where all you actually are going to be given is you'll only be given 2 pieces of information. What element has 18 neutrons and an atomic mass of 36? Now, what I have is here's my neutrons and protons. So I'm still going to take 36 and subtract 18. And yes, I am absolutely getting a calculator for that because I was pretty confident that was 18, but just double checking. That's my number of protons. So now that also means that 18 is the atomic number. I am using the number 18 way too many times. Oh, too late. Too late. And so now I can find my atomic number 18, which is argon. So I did actually have to do that subtraction. I should have picked some different numbers. I can pick different numbers. I'm mad at me. Hold on. An odd number. Nope, nope. Too many. Oh dear. 17 neutrons, atomic mass of 35. 35 minus 17. Now we have 18 protons. Now argon is the atomic. Now 18 is the atomic number. So 18 is my atomic number, not 17. I feel better about this. Argon is what I'm looking for. So I still got argon. Sorry. I did not like the fact that I used the number 18 over and over and over again. So I had to fix that to make me feel better. Okay. So it is 6:30. What I do want to know is if there are some more questions in the chat.
We do have some questions, and I can send them to you in an email, unless you'd like me to read them out to you now.
Can you read them out to me now? Because that way I have them. That way they're here.
I can go ahead and do it. Oh,
Go for it.
do you want me to go ahead, Jenny? Okay. All right. So can you go over the uncertainty principle and the Rydberg equation?
Okay.
Are there any specifics that we need to know about the experiments, precursors like Thomson cathode rays, etc.? Do we need to know the different chemists like J.J. Thomson or Dalton and their experiments? Do we need to memorize the different wavelengths and know the exact numbers? Do we need to be able to write noble gas configurations for the exam? And let me see if I'm missing anything. Those are the last few that I see.
Great.
Yeah.
Fabulous.
Hold on, there's a couple at the bottom, I think, from a while back.
Oh, okay, go ahead.
Okay. Yeah, no problem. I just want to make sure they get answered one way or another. It's being really slow.
And I will check my email. So if that's the best way to do it, we can do it that way. I just thought if it was fast, then we do it this way. But if email is what we need, we can do it that way.
Okay. Do you want me to go ahead and read these still, or
if it loaded, sure.
Okay, it loaded. Okay. Will there be a timer that shows the exact time during the exam? Someone else answered that in the chat, but can you go over M's Subel, L, and N working through a problem? How many points is each question worth? Multiple choice question and short answer. Should all work be done on the provided scratch paper? I think you answered something along those lines.
Yep.
Are we allowed to bring our bags into the exam room? Can you go over diamagnetic elements and line spectra? Another bag question. There's like two more or something. If we go over exam one practice test, would we be good for the exam? Like, are those the only kinds of questions that we would see on this exam? Can you go over the can you go over the S and P orbital graph? Are there any specifics we need to know about the experiments researchers like Thomson cathode rays? Think you just got that question. I believe. Oh, it's the same question. Do we know all formulas and consultants such as wavelengths, etc., equations, or speed of light constant, or will we get a formula sheet? I think you answered something along those lines as well. Do we need to know the different chemists? Another chemist question. And that, I believe that is it. Oh, and then what is the appropriate way to draw an arrow in the exam?
Okay. Now we talk about arrows. Okay. So the only one I really want to address real quick is y'all always, so the old exams are just old exams. It's not a practice exam. It's just last year's exam. That's all it is. So one thing that I want to point out real quick is the front page of this old exam has 4 names on it. Wong, Diekman, Taylor, Hashami. Dr. Hashami is fabulous. I like her a lot. I also really like Dr. Enka. I like her a lot too. The instructors on the front cover of your exam are also the authors of the exam. This has an author that we don't have this semester, and you have a brand new one in her place. So Dr. Enka doesn't write questions like Dr. Hashami. I don't write questions like Dr. Diekman, and we rotate who writes which questions every single year. Because that way I don't write nothing but quantum number questions, which would really annoy me. We rotate through. So no, just this exam is not enough. You need to be, the reason why I do like the old exam is because the questions are in a random order. And for all the questions folks asked me about wording, this usually helps calm people down a little bit because of that. But no, it's got different authors. Different people wrote it. So it's not the same. Can't be. Okay, that's all. We should wrap up now. I will make a follow-up video. Just so y'all know, I will make it tomorrow morning. As I will not, my brain has done enough chemistry today. So it'll be tomorrow before I make that thing. But that'll at least get us through a fair number of things.
Awesome. Well, if that's everything, thank you all for coming. Thank you, Dr. Taylor, for leading our session. Thank you, LLAs, for moderating our chat. And we'll see y'all next time.